Hello students, in this lecture I will describe how to form the equation and how to draw the free body diagram of a problem with inclined plane and some body which is about to move. So let's get started. So there are some problems in your textbook and in your exams. These problems are very common, that there is an inclined plane and a body is resting on this plane and some force is acting on this body, and this body is about to move in upward or downward directions. Those instructions were given in the question. For example, see on the left figure, this body is about to move on the upper directions, so the frictional resistance will be in the opposite direction. Here and here, first one and the third one, in both cases the force is applied is parallel to the plane, okay, but the motion is this here. In this case the motion is and the force is in the same direction, but here the force is applied in the upper directions, but the motion is on the bottom directions because of the body weight, self weight. Okay, so these are a bit different but almost similar because the forces are along the parallel planes, the inclined planes. But here this is a bit different because it is about to move in the upper directions like this one, but the force is horizontal, not the parallel to the plane. So let's see how to draw a free body diagram for these cases. First, look at the left figure. To draw the free body diagram, first we have to draw the force which represents the weight W, and then let us draw the force, the reaction force. That means the reaction that from this plane to this body. So this is a 90-degree or normal reaction, that is why we write it N. And then because this is about to move on the right direction, so the frictional resistance will be on the left directions, and this is a frictional coefficient into N, Fn, because N, this normal reaction, is multiplied by some coefficient. This is called coefficient of friction. So you can see there are four forces in this system, 1, 2, 3, 4, and we have four variables. That means four things that can change value. That is, W can have different values, N can have different values, small f can different values, capital F can different values, and the fifth one is the theta. Theta can have different values. So we have five different variables, and we have two equations like summation of components in x direction, summation of fx equal to 0, summation of fy equal to 0 for a static body. So if there are two unknowns and three known, then we can solve this problem. And look at the angles. Here the theta, this angle is here. You can prove it by geometry, but I explain it like this. This horizontal plane and this is the inclined plane. There is an angle between them, and this is the vertical on the horizontal plane, this is the vertical on the inclined plane. So two verticals have the same angle, two planes have the same this angle, and two verticals on these two planes have the same angle. Or you can explain it in many ways by geometry. Okay, so let's go to the second one. Here the problem, the same thing, the vertical, the self weight, normal reactions, and the frictional resistance. And here the same thing, the self weight, vertical reaction, and the frictional resistance, because motion is in this direction, so frictional resistance in this direction. So if we want to solve these systems, now we have to write the equations. But before writing the equations, we have to define the axis, the reference axes. So let me draw the axes like this one. The axes are parallel to this plane and the vertical to the plane in all cases. Okay. Well, we can draw the axis like horizontal and vertical as also, but I am drawing this like this now and solve it with this axis, and later I will explain it with the horizontal and vertical axis. Okay. So let's start with the left one. So you can see I have divided this force into two component forces because the other three forces are along any of the axes. So this doesn't need any component forces, but only this force makes an angle with the axes. So we have to distribute or resolve it to component forces which are parallel to any two axes. So now we have everything ready. We can write the equation. So summation of forces along x should be F minus Fn and minus W sin theta, and summation of y should be this n and minus W cos theta. So these are the equations. So pretty simple. For this figure, now we come to this figure. Two forces are making angle with the axis, and two forces are along the axis. So these two forces should be resolved like this. So, oops, what happened? Yes, this force is we have to resolve this force, and we also have to resolve that force as well. So look at the angles. So notice the angles here. This line and this line are parallel. So this is theta and this is theta as well. And here same theta. These angles, and here this is horizontal, this is horizontal, this is inclined, this is inclined parallel to inclined. So this angle is this angle. Okay, so this is F force, and so this is F cos theta, F sin theta. Now we can write the equations very easily. You can see the summation of Fx components along x is this. Instead of F, this is F cos theta, then W sin theta is negative and Fn is negative. Okay, and along the y, the n is positive, W cos theta negative, and F sin theta is negative. Okay, this is almost similar to this, because three forces are along the axis, only one force need to be resolved. Okay, we write it down. This is theta, because this is theta, so these two are parallel, so this is theta and this is theta. Okay, now we can write the equations. So the x positive side is, so W sin theta is positive, F is negative, Fn is negative, and for y this is positive and this is negative. Okay, so now I will show you. This is enough to I hope that you can now construct these free body diagrams with more confidence and with understanding, and you can understand the solved problems that I have provided you. Okay, now I shall show you, if I draw these axes in other way, that means horizontal and vertical, what happens, and what will be the equations. So before that, I am removing this equation here. I am keeping this equation here, and I will derive new equations for the new axis. So I am now rotating the axis and placing the axis here. So this is horizontal and vertical. Now you can see this force is already along the new axis. We don't need these components anymore. So we have to we don't need this. Okay, now we need the components for these three forces, because these are making angle with the axes. So we have to distribute these three axes. So this is the original ones, that means when the axis was inclined, this inclined axis, for these are the equations. Now for this horizontal and vertical axis, let us see what happens. So we are resolving three forces which makes an angle. So this is theta, this is theta, and this is theta, so this is theta, and this is theta. So these are the components and these are the equations. So now you can see, you can compare these two equations. Here only one among the three forces, only one has theta, cos theta or sin theta, but here three of the forces all have thetas. And for vertical directions, these are pretty simple, only two terms, two numbers, but here 1 2 3 4 components, and among these four, three have theta. So the solution will be a bit tricky, and the figure is a bit hazy, because not simple anymore, because previously figure was pretty simple, right? Now you have to draw components and write these things on the figure, otherwise you will lost your way. So that's all for today's lecture. So hopefully with this knowledge, and hopefully if you can draw axes along the planes, that will be beneficial for most of this kind of problems. And with this knowledge you can solve hopefully you can understand the solutions provided here and how these figures are drawn, and you can try it yourself and then match them with these worked out problems. Okay, here this kind and this kind both are here, but the relation between this force and this force is described here. Okay, and here the similar problem but two parts, and the forces relation between this force and this force is described here by this is similar to another problem we have done during the moments. Okay, and this is another problem, a bit tricky but interesting. Everything is described here, how is it is done. If you have any problems, please ask me in the next class. And the last, this is the most tricky problem. It is not tricky, but it is very lengthy problem, and we were very afraid because there are many forces we have to draw in a small place, so we sometimes lost track which I have written and which I have, because you see, after writing all these forces, it is very difficult to draw all these component forces and write them here. So that is why it is tricky. Otherwise things are almost as simple as the previous ones, but we have many forces and there is very small space to write everything down. Okay, that's all for today. Thank you for watching this video.